Alright, AP Calculus Chapter 2 Continuity, and this is video part 5. Practice problem set 2. Is the function f of x given as piecewise function continuous at point x equal 2? Let's see. Let's do the test. Three conditions, right? First, f of 2 is given equal to 9. As we can see here, it's 9. And this is condition 1, satisfies. Limit of f of x as x tends to 2 minus is equal to the limit of which f of x we choose. X tends to 2 minus means x less than 2. So we have to take the x plus 7 and substitute 2 plus 7 equal 9. Then we find the limit of f of x as x approaches 2 plus. It will be limit 2 plus means where x greater than 2. It's 3x plus 2, right? 3x plus 3, right? And also when we substitute 2 instead of x, 3 times 2, 6 plus 3 equal 9. This means limit of f of x as x approaches 2 minus equal to the limit of f of x where x approaches 2 plus, and this is condition 2 satisfied. Still the third condition. The third condition says what? The third condition is the limit is the limit of f of x as x approaches to, which is this both, since they are equal, right? Because they are equal to 9. This means this equal to 9, which is equal to f of 2, and this is condition 3 satisfies. So f, yes, is continuous at x equal 2. First problem, continuity, is done. We have 10 problems to finish. Let's see. Okay, let's see number 2. Number 2. Also same, but we have to study the continuity at x equal 3. First, f of 3, we substitute it here, x equal 3, right? It's 10 times 3 minus 1 is 30 minus 1, which is equal to 29. And this is satisfies the existence of condition 1. Condition 2, limit of f of x where x approaches 3 minus is equal to the limit of 4x squared minus 2x, because x tends to 3 minus means x less than 3, where x approaches 3 minus, we substitute 3. It's 4 into 3 to the power 2 minus 2 into 3. The answer is 12 minus 6, sorry. The answer is 6. And limit of f of x, right? Limit of f of x. Answer is not 6, sorry. This is 3 squared, which is 9. 4 times 9, 36 minus 6. The answer is 30. Limit of f of x where x approaches 3 plus equal. Limit as x approaches 3 plus means x greater than 3. And it is here. It's directly given as 30. Right? Limit of 30 is 30. It's constant number. So we have limit of f of x as x approaches 3 plus is equal to the limit of f of x where x approaches 3 minus, and this is satisfies. This gives me that limit of f of x as x approaches 3 plus 3 minus is equal to 30, and this satisfies the condition 2. Let's see condition 3. Is this limit of f of x as x tends to 3, which is equal to 30, is it equal f of 3? No. because f of 3 we found it at the beginning and it is 29. This means condition 3 not satisfied and f is not continuous. F is not continuous at x equal 3. Okay, let's see number 3 now. Let me remove those. Erase them and continue. Let's erase as much as we need space, and we can continue to number 3. Number 3 is f continuous at point x equal 3. Also, let's see. First, what is the domain of this definition? What is the domain of definition of this function? Right? First, we should find f of 3, because where we are working at x equal 3, the function should be defined. Is f of 3 exist? We have where x less than 3, we have where x greater than 3. 3 we don't have it at all. So f is not defined. And this is the important thing to start with, right? Domain of definition. Since f is not defined at x equal 3, we don't have x equal 3, then f is not continuous. How can be continuous if this point not exist? So f is not continuous at x equal to 3. Number 4. Number 4, he's asking if f of x, which is equal to secant x, continuous everywhere. What's the meaning of everywhere? This means over all Earth, right? Is it continuous at everywhere? What is secant x first? 4. We start by secant x. What is secant x equals to? Right? Secant x is 1 over cosine x. Let's see. Since we have rational fraction, we have to say that cosine x should not equal 0 because it's found in the denominator. This means cosine x should not equal what is 0. It's cosine pi over 2, right? This means that x either could not equal pi over 2 plus 2k pi, or x does not equal here, minus pi over 2 plus 2k pi, where k belongs to z, right? So every odd multiple of pi by 2, every odd multiple, because from pi by 2 to minus pi by 2 in the trigonometric circle, what do we have? We have pi. So this will repeat itself every pi, right? Every pi. Here cosine is not defined, and here cosine is not defined. At each pi over 2 or minus pi over 2, which is 3 pi over 2, which is, if we take here, k is, or here, in this one, k is 1, then minus pi over 2 plus 2k pi plus 2 pi is equal to 3 pi over 2. So what is 3 pi over 2? This one is 3 pi over 2, which is 3 pi over 2 or minus pi. This means every odd multiple of pi over 2, every 1 pi over 2, every 3 pi over 2, every 5 pi over 2. This is not continuous because it will be in the denominator will be 0 and the function will be not defined. So no, it's not continuous. F is not continuous. Secant x is not continuous. Let's see. Number 5. Is the function secant x continuous on the interval minus pi pi? Let's do it here. Okay, number 5. Sorry. All right. Is number 5, let's secant x, y equal secant x. Again, it's 1 over cosine x. Is it continuous on minus pi pi? Same thing, right? Same thing, since minus pi over 2 and pi over 2 is not in the domain of cosine x, so secant x is not continuous at minus half pi and half pi.